Hi, IB. Here we go with graphing our tangent function. So a little bit different than our sine and cosine. Let's see what happens. Remember that your tangent is your sine divided by your cosine. So if I label, let's just take some basic increments. So at 0, remember our cosine and sine will be 1 and 0. At pi over 2, we have 0, 1. At pi, we have negative 1, 0. And at 3 pi over 2, we have 0, negative 1. And let's even go one step further. Let's say we have a 45-degree angle that we stop right here. So 45 degrees, your sine and cosine will both be 1 and 1. So tangent is going to be 1. 1 divided by 1 is 1. So here is tangent at 1. It has a value of 1 at 45 degrees. So if we have a 45-degree reference angle in the second quadrant, tangent's going to be negative 1, and so on, positive 1, negative 1, as you head around the unit circle. So let's see what happens when we actually map this out. Let's say we start at 0. Sine divided by cosine, 0 divided by 1 will be 0. So we do have a point at 0, 0. Let's go to pi over 4. So we'll go halfway between 0 and pi over 2. At pi over 4, we have 1 divided by 1. So we have a y value on our graph of 1. When we get to pi over 2, 1 divided by 0 is an undefined value. And if you remember from our rational functions, that is when we get an asymptote. So we actually have an asymptote at pi over 2 that we are going to mark with a dotted vertical line. And that just means that we actually have undefined values at pi over 2. So there are no x values at pi over 2. When we have an asymptote, we're going to draw our curve really close to this asymptote, but we're never actually going to touch it. So let's see what happens on the other side of the asymptote. Again, increments of pi over 4. So that will be halfway between pi over 2 and pi. We're in the second quadrant where tangent is negative. Again, it will be 1. So I'll be down here at negative 1. At pi, we're back to 0 divided by 1, negative 1, which is 0. Increments of pi over 4. We're now here in the third quadrant, where my sine divided by cosine is going to be positive 1. And now we are at 3 pi over 2. And at 3 pi over 2, we have negative 1 divided by 0, which again gives us an undefined value because we're dividing by 0. So there is my vertical asymptote. So again here, I've got the same half that I had in the first half of our unit circle. An upward facing, this looks like an upward facing parabola, or part of it. And then we have this second half, but I need to approach this left asymptote. So I actually have a concave down shape, so it looks like an upside down parabola, and then it links with a concave up shape. And this is a right side up parabola. So if we notice that I can continue to go around the circle, but the same pattern is going to wind up repeating. So let's say I started at 0 and I moved in a negative direction. Again, here at increments of pi over 4, that means that the second half would wind up being here at negative 1. I'd have the second half of my tangent curve. And again, at negative pi over 2 is where I would wind up having this asymptote. All right, and this will continue for as far as my window is drawn. So if I think about an amplitude, do I have a max or a minimum value that this graph will go to? It actually will continue to go up to positive infinity and negative infinity, so we don't call this an amplitude, all right? I don't actually have a max or a minimum point for my tangent graph. The principal axis is still at 0. The period, though, how long does it actually take tangent to start a new, to go around a second time, basically, to start again? So at this pi over 2, I begin again, and I go from pi over 2 to 3 pi over 2, or from negative pi over 2 to pi over 2. So I actually just have pi units. So tangent has a little shorter period than sine and cosine. It's half. So our period for tangent is pi units. And the asymptote occurs, well, the first one starts at pi over 2. And then it occurs every time we have another revolution, so another pi units. So I start at pi over 2, and then this is going to continue for every increment of pi. So what we're going to say is every k value times pi, where k is an element of the integers. So in other words, if k was 1, then my next asymptote would happen at pi plus pi over 2. If k is 2, then my next asymptote would happen at 2 pi plus pi over 2. So every interval of pi units, I have another asymptote. So please make sure that you guys have the general form of the tangent function written down, and go ahead and identify the two changes that are going to happen in this next example. We have a horizontal shift left by pi over 4 units, and we also are going to move up by 2 units. So remember that 2 units of shifting upward is going to change my principal axis to now be positive 2. The period, there's no b value other than 1, so my period is going to stay at pi units. The amplitude, again, we have none, and we did just identify we have a horizontal shift left, and we also have a vertical shift upwards. All right, so think for a moment where we would like to put our beginning point. Where would our first point be, and what would our increments wind up being? How are we going to mark our graph? So I went ahead and labeled my x-axis and my y-axis the same as the last graph that we did, because we're still looking at pi over 4 units. So I went ahead and just marked our increments of pi over 4 along the graph. Now notice if we're starting at, I'll use green for this, if we're starting left pi over 4 units, that means I've shifted that 0, 0 point to the left by 2. All right, so now I'm starting here. However, my principal line is also up at 2. So let's go ahead and write in our principal line at 2, and let's draw that in just so we have a starting point. All right, so going back to green, if I'm moving left by pi over 4 units, that means I'm going to work by transformations. For my original graph, I have a 0, 0, and then an increment of pi over 4, I have positive 1, and to the left, I have negative 1. So looking at this transformed graph, I'm moving left pi over 4 units, starting up 2, so this is where my 0, 0 has moved to. Remember, we also had a point at pi over 4 and 1, so that means if I move from that original point, pi over 4 units to the right and up 1, there's my positive 1. And then if I move pi over 4 units to the left and down 1, I now have this middle section of what my tangent curve is going to look like. Right? So if I add pi over 2 units to the right and pi over 2 units to the left, that is where my asymptotes are going to be. So I can go ahead and draw in. My asymptote is shifted from the pi over 2 where it normally is on the parent graph. It's moved left by pi over 4 units, and same on this left-hand side. Once I have one section of tangent drawn, then it will be a little bit easier to repeat. And I can continue this for whatever window I'm asked to draw. So again, every pi units, I'm going to have my asymptotes. So here's 1, 2, 3, 4. There's going to be another asymptote in the window that I've drawn. And otherwise, I would have one kind of down here if I continued my window. All right. And again, I can go ahead and take my middle point to the right pi over 4 and up 1, to the left pi over 4 and down 1, and I can go ahead and have a really pretty accurate graph of my tangent function. Best we can here on the smartboard. And then same here to the left, and I've got a really nice accurate graph. All right. So here my asymptotes are beginning at negative pi over 4 because of that horizontal shift, but I'm still going to add on units of pi because my period did not change, and that's where k is an element of any integer. There we go. All right, so just thinking about how the asymptotes will be affected by where your horizontal shift is. Principal line is affected again by where your vertical shift is, and if we have a period change, then we will also have to change how wide or how far apart the asymptotes are. Last but not least, if you were given an example with a period change, so notice this -3 is a vertical reflection the 3 stretches it in the vertical direction, so that will change how vertically stretched your graph is. However, the horizontal stretch is affected by the period, and normally we would divide 2 pi by the b value, but now that the period of tangent originally is pi units, we would divide pi by the 2. So pi divided by your b value is going to be the period for your tangent graph. All right, so we might have some in the future where we'll graph those as well. Otherwise, have a good night.